Hey everyone, welcome back to Pydjango-Tutorial channel where we make Kubernetes super easy to learn step by step. So if you're new here, don't forget to subscribe so you don't miss the complete Kubernetes playlist. Today we're going to talk about one of the coolest feature in Kubernetes, the Horizontal Pod Autoscaler or HPA. So imagine your application is under heavy traffic and Kubernetes automatically scales pods up. And when traffic goes down, it scales them back down. That's exactly what HPA does. So what is HPA? So HPA automatically adjusts the number of pods in a deployment replica sets or stateful sets. It works by monitoring metrics like CPU usage, memory, GPU usage, or even custom metrics that you can define. So it is a must-know concept if you're preparing for Kubernetes exam, or if you're having a certification exam, or if you're just trying to learn Kubernetes. It is something that is very important and very useful when you're deploying or creating a production level application. So how HPA works is you define a target metric. It could be anything. It could be custom metric. It could be CPU usage, GPU usage, or memory usage, or number of connections or pending connections in the queue. It could be anything. The metric server collects part usage data. If, let's say, CPU usage goes beyond the threshold or beyond the target value, HPA adds more pods. If usage goes below the threshold value or the target value, it scales pods down. How to do this in Minikube? We'll have a live demo as well, but steps that you have to follow are just start the Minikube, enable metric server, deploy a sample app. We already have a deployment services and pod running, so we'll use the existing ones. We'll use BusyBox image to generate the load and watch our pods scale up and scale down. Now, very first thing you have to do is start the Minikube. Obviously, I have my Minikube running. So I'll do Minikube status. It is running. Now, for metrics to work, we need to enable the metric server itself, just like we have enabled Ingress controller. So it's Minikube add-ons enable metrics server, and our server is enabled now. It will be easier if we have a separate demo application that we will deploy in our Kubernetes cluster just for HPA. So I have the script or manifest already, and you can find all these manifests in the GitHub repo. The link is in the description. So let me create a file. I'm gonna say demo hpa.yaml, and let me just paste it. So let's see what's going on here. By the way, this is another way of creating all the resources under one file. So you can specify your resource, then these three dashes, and then you can specify another resource. So what's going on here? I'm just creating a simple deployment with HPA example image. This is a publicly available image you can use. Then I have a service that's basically exposing this deployment called demo. And I'm selecting the deployment based on the labels. Also, this is the good time to start using the namespace as well. So I'm going to specify namespace and my resources as well. No, our namespace is not default, it's demo namespace. Similarly, I can specify namespace here as well. Now it's time to apply this YAML. So I'm going to copy the path into my terminal, kubectl apply -f, let's change the path to Linux. Let's hit apply. So our deployment and service is created. Now if I do kubectl get svc, svc is short for services, and in my demo namespace. So I have the service of type cluster IP. Now let's create HPA. So I have this command, which I'll provide in the description as well. So all this is doing is create an autoscaler for the deployment demo deploy. And we are specifying that if CPU percentage usage goes beyond 50%, then start scaling my application. And min is how many minimum replicas I want always to be running, and what's the maximum number I can go up to. So I can go up to 10 replicas in this case. But you're getting error because we have to specify the namespace as well. I'm going to say demo deploy, then -n demo namespace. Now it is created. So if I do kubectl get HPA, which is short for horizontal pod autoscaling, in demo namespace. This is what I get. So targets, you see right now the usage is only 1%, and I've set the threshold as 50%. Min parts is 1 and max parts is 10. Right now the replicas is 1, and you can get more detail if you do describe on this. So kubectl describe space. You can see more details here that right now the desired count is within the acceptable range. That's why nothing is happening. But once this number goes beyond 50%, it will start auto scaling itself. How to do that? We'll generate a dummy load and see. So let me just clear this. So now let's generate the load so that our CPU usage can go up and our pod can start auto scaling based on the number. So I have this command. I'll paste the link, or I'll paste the command in the description of the video as well. So I'll open the new Ubuntu terminal, and in the terminal, this is my command. So this is just creating another load generator pod using the image busybox, and I'm executing into the pod. Now I'm inside the pod. Now another thing I'll do is just create a while loop that will constantly hit my service. And based on that, because it's a while loop, infinite loop, my CPU usage number should go up. So I'll paste the command. Now this is how internal DNS works in Kubernetes. So you have your service name and the namespace, and you can use these interactive name instead of the IPs. Now, because I'm in the same namespace, like my load generator and my service is in the namespace, I don't even need to do this. I can just say HTTP demo service, and it should be good to go. So OK means it's able to hit my service. Now in this terminal, I'm gonna watch my namespaces. So I'll say kubectl get HPA -n demo namespace and W. W means watch, so watch for any event. So right now you see that CPU usage has gone up to 56%, and you should see my pod number going up. So if I open another terminal, or actually let's see here only. So if I do kubectl get pods -n demo namespace, you see I have two demo deploy pods running. This one is only 24 seconds old. That means it was because of my HPA. Now, if I check my HPA again, you should see that I have two replicas instead of one now, because my HPA has auto scaled my pods based on the metric or based on the threshold for the CPU usage I have provided. Now, if I check the events within the HPA, so I can say kubectl describe HPA, the name of my HPA is demo deploy, and that is in demo namespace. You can see all the events. So new size was 2 because utilization was more than the target. Then just 7 seconds ago, new size was 3 because even now the utilization is more than 50%. Now let me kill my infinite loop and just wait for HPA to scale down. Right now, if you can see, the target is 145%. That's way beyond the threshold value, and that's why HPA is scaling my pods. So you can see utilization is coming down, and slowly HPA will start decreasing the number of replicas because my threshold value is less than the target value. So we'll just wait for that to happen. So now you see the desired replicas is again back to 1 because all the metrics are below target. Now remember that scaling down can take time because there's a cooldown period of 5 minutes, I guess, by default, and that is to prevent the rapid fluctuation in the metric or something. So it can take time. It wouldn't be immediately, so don't worry about that. So that's it. You just learned how Kubernetes automatically scales or handles scaling with HPA. And also, by the way, if you're preparing for Kubernetes exam or learning Kubernetes in general, I've put together a handy PDF cheat sheet with all the important commands and best practices when managing a cluster. You'll find the link in the description. Please check it out. And doing that, you'll be helping the channel as well. So with that, thank you so much for watching. And in the next video, we'll explore another key concepts of Kubernetes. So stay tuned. And if this was helpful, hit like and subscribe for more practical tutorials on this channel. Thank you so much for watching.